So it says when numerical data distribution is skewed, the degree of skewness decides which central measure should be used. Now, that from what you have here, we already know that if it is a normal distribution, what you have is like both the mean, the median, the mode, all of them will be in the same spot. They fall on the same number, the same value. But now, so that when it is skewed, skew is like it is not symmetrical like it is in the previous diagram. It's not symmetrical, which means okay. Symmetrical is like this one is symmetrical because if you divide that bell into two, the same shape, what you have in the left will be the same in the right, which means the shape will still be the same. They look identical. But in the case of skewed or distribution, which means at the left side might be steeper than the right side. So in that case, what determines the measurement, which means how will you then measure? That the degree of skewness, which means the degree of steepness, so of either side will determine the measure that will be used, the centrality measure that will be used. So that when a numerical distribution is skewed, degree of skewness decides which central measure should be used. Now, that skewness is a measure of whether the distribution slopes toward the left or right or is balanced. I said that when you talk of skewness, I said that this is a measure of whether the distribution slopes towards left or right, which means it can slope towards the left or to the right. Now, I said that as the skew increases, the centrality measure for data changes. So that the more the increase in the skewness, whether the centrality measure for data changes. So which means for unlike this, where everything falls. So by the time it begins to skew now, so all the centrality measure will begin to change. The value will not be the same again, so it will change. So now let's say an example. So now that if the distribution is not skewed, both mean and median will have the same value. So even both mean and median. That if the distribution is not skewed, so both mean, median, and even the mode, they will have the same value. All of them have the same. There's no skewness there. For example, the skew when placebo is used is 0, and hence the mean and median will be the same. So placebo, when you look at the placebo is this one that has this blue line here. Placebo is the one last one, the unit of placebo, which is this. So and then when you look at it, it is like it's a normal distribution, both at the left and at the right. So there is no more steepness between them. So that's why they say that. Though it doesn't resemble bell shape, but let's say it is balanced, like we said. It doesn't skew to the left or to the right. It is balanced. So say that, for example, to skew when placebo is used is 0. And hence the mean and median will be the same. So with placebo now, say that the mean and the median will be the same. So and then when you look at that, they are representing 4 graphs here. We have the one for smartphone, which is the blue one that is here. And then we have the one for tablets, which is this red. Then we have the one for confectionaries, which is this green. And then placebo is the one that is, I think this color is purple. So placebo is the one that has that color. So and then apart from placebo, the other ones are not balanced. So some skew, most of all of them skew to the. Okay, I think no problem. I think this one skewness is left. So let's go on. Now, first, for example, the skew when placebo is used is 0, and hence this means it has no skewness. The skewness is 0, and hence the mean and median will be the same. So after that, let's say, okay, but the other ones they are skewed, and then then what decide whether it is to the left or to the right? I think the peak will decide it. Where we have the peak, and then decide where this one skewness is steepness. I think this is to the left. Sorry, to the right. The steepness is to the right for the first one. Which one is this? Confectionaries. And then for the other one too, for the one in blue smartphone, I think it's to the right too. And then which other one? Confectionaries. The one with the red. Where is the peak? Most of them are to the right. The steepness to the right. So let's look at the skewness far. We'll be able to tell. So that the product unit, okay, that the product unit sales of e-retail store in the department is here. You are required to check if the data is skewed. So you want to check if the data is skewed. And if so, is the distribution skewed for all, one or two of the departments? Data for a department called placebo is used to provide an indication of a perfectly balanced, that is, skewed distribution. So let's see how go about that. So let's look at the before I'll put in two files. We look at the input, that is the one that asked the question. They are asking us the let's say we call it the question file. Okay. This is one that contains the problem that we want to solve. This one contains the problem. We call it input file. Let's see the content before I open it up. So it's open up. Open it soon. Okay, so let me share it to you. This is the question we are having. This input file. We are given this file. So I think it's something that we have. Look at something we have done before. I said that this one is added to it. Placebo is added to it. Placebo. And then I think this should be easy. Let's see. Normally, the skewness of placebo, if it is placebo, is supposed to be zero according to the graph. So according to what we, so let's try to calculate skewness. And then to calculate skewness, what we need is there's a formula in Excel for calculating skewness. So what we just do is just come here, search for skew. Let's do EW, and then let's see. See skew here. So then which one should we use it? Or at least let's see. We can use it too. But the one that returns zero is for the, let's say we have choose the first one. And then saying we should show our data. Our data should be, so let's see, our data is from so from here for skewness, if we get zero here, which means we are correct. So here, so then that is it. What else? I think we are correct. We're saying the skewness is zero. So that is skewness for that. Now, let's now try for the others. Okay, we don't even need to stress ourselves. We can just flash fill it. So to know whether we are right on skewness. So now for all this, one, it's supposed to be one.
See,
So sorry, I have to attend to some things. So now, let's say from our skewness, we can see that this one, okay, which one is it? The first one. For the first one, okay, so how of the day? So how of the days of we are not supposed to answer for how of the day. Anyway, so it's answer that the said skewness is 0 to that. I'm removing this. Okay. Now for the other one, we have this one is skewed to the at least all other ones are skewed. This one is 0.1, this one is 0.42, this one is 1.1, then this one is so I think so. Then let's see the graph. Okay, there's a graph here. Oh, sorry. Let me see if I can start uploading the video to the first class, the first statement, not too much. So I'm trying to send the video that we did for the first session we had that timeout. Let me send that one to maybe it will be able to load before the class ended. Okay. Who is it? What's the difference? Today is 26. I hope this will load before we finish. The size is not that big. Sometimes it's take some time for the test. So now let's go on. Let's say that this is skewness. This one has okay, I'm trying to do the file. So now this is the graph for all of them. So being plotted together. All of them being plotted together. We have and then most of them skew to the right. Because you can say that if it is negative, okay, I think there's one that is negative there. Is there? So the one that's negative is one that's all of them to the right. So which means the skewness is to the right for all of them. For all of them, the skewness to the right. That's what we are having. So maybe we should let's try and plot them ourselves. So just the same way we plot, all we just need to do is just select the everything against the hour. So all we need to do is just select all this, go to the hour of the day, we bring the table, then to this place, then we set our graph. Set our graph. Basically, it's supposed to be line graph. We use scatter plot, and that would be better. Let's use scatter. That one will be smoother than the line graph. We use this one. This one is smoother than that, and then we click. Okay, so this is it. And then whatever information zero. We can add our own labels. Label. Put the legend to the right. Right? I used to do legend. Put the legend to the right. When you look at the steepness for all this, so when you look at the peak, and then this one is steeper than this side. Then for all of them, the they are the slope to the right is steeper than the other ones. So that's why we're having it as positive. But if it is negative, which means the one at the left is the one that is steeper than the one at the right. So that is that. Okay, I even have one here. This one also is part of it. Which means I've made my selection is wrong. This one here, all of the days not supposed to be. Can I remove? Okay, I'll remove it. So that is that. So then let's see. Yeah, that is that for the skewness. And then the other, what is the distribution when the skew is 0? So any answer to that? Answer to that? Sir? Sir? You say?
I'm thinking it's balanced.
It's balanced. Okay. So when skewness is 0,
When distribution,
the distribution both at the left and the right are so. No, you are right. You are right. You are right. It's balanced. So when it's 0, which is balanced. So you are correct.
Right.
So now let's go on. So then the next one says, okay. Now says that when the distribution is non-skewed, the central measure used is the mean. So this is the condition when you are. So which measure to use when you have skewness or when you do have skewness? Now, when the distribution is non-skewed, the centrality measure used is mean. Which means you use the mean. Which means if it has no skewness, it is 0. The skewness is 0. You use mean as the centrality measure. Then usually under such condition, the mean is the same as the median. Under the condition where we don't have skewness, then this mean is usually equal to the median. So the two of them are the same. Though this is not normally distributed like this, it's not normal distribution, because if it is normal distribution, it will look like a bell shape. But from what we have from the diagram here, though it's not bell shape, but there's no skewness in the graph. So that we use the mean and we use the mean as the centrality measure. Though the mean and the median are the same, but you use the mean. So that is the first one. Then the mean is an excellent centrality measure. However, it is extremely susceptible to the value of the data point from which it is created. It is extremely susceptible to the value of the data point from which it is created. Now, what they are trying to tell us is that with mean, the value of the data set affects mean more than the other centrality, other measure of centrality, like mean, median. Like now, if you have a value that, let's say, wide range of value, then those values that you have, the value for each of those, that data set, let's say we have data set, then the value in the data set affects means more than median. It's like now, when we talk of median now, like the example I gave the other time, some times back, let's say we have value like, let's say we have one, I want to use one like this. Let me use this space. We have 1 to 5. 1 to 5